Everyone's here today, right?
We're right on the verge of forming a precipitate with the two ions in question. So we can simply use the Ksp expression and the concentration of one ion to find the concentration of the other ion.
Would you like me to pause this? Are you filling things in? Yeah. I don't have my book today. I don't know where it is. So if you guys just tell me to pause, I can stay paused until I see you not writing anymore. Is good? Okay.
Let's do an example problem. We are given that we have 2 liters of 0.01 molar copper nitrate solution in a beaker. We're asked the mass of solid KiO3 that would need to be added to this solution to just start precipitation. We assume that the addition of a small amount of solid KiO3 will not affect the total volume of the solution in any significant way.
Okay, so we are adding some KiO3. We're adding it as a solid, so we're not changing the volume, at least not significantly. Do you guys think if you had some like paper that you could solve this? Go get a piece of paper and see if you can solve it. If you get stuck, if you don't know where to start, call me over, okay? So I have, yeah. So we have, I take the data sheet.
Just our Okay, so it's like 0.01. Wait, why? Zero point zero one. What's the concentration? Does it matter?
Oh, that's what I like. The moles would be 0.02 for 2 liters.
Never mind.
Oh, yeah, you're on the wrong. Okay, given the question, we know that it's not like that's not. I would definitely.
You have a beaker containing copper nitrate. So copper.
Oh, yeah.
And then the iron three is just gonna dump in a salt. Are they gonna be reported?
Are you gonna sing?
We're not done. Right?
But if you get right, yeah, you did 3 times.
Oh, you didn't say. It's like a 1-1 ratio, right?
Oh, no, it just, that won't be the same. So then you have a square root.
So would this be where you multiply by 2 meters?
I think so. And then you.
Oh, I think so. We're not finished yet. What was their concentration?
Anyone need a hand? How are we doing? We're coming along. Oh, that looks so good.
There was a square root case, I guess.
How are we doing? Okay, so we have our. We have this.
I got one. This one. Yeah.
Oh, right.
I'm completely wrong.
Oh, yeah, you were there. It's lined up. Yes.
Oh, yeah. What? You got one.
There we go.
That's nice though.
We got 1.1. We got 1.1. What do I have?
Yeah.
I just need to know what you're. Thanks for.
Okay.
Then, Should be on me. That's what I.
And you don't have to show them.
It might be fun.
This is what we're doing.
Yeah.
Right.
Yeah.
Okay.
Yeah.
So you want to rate
99.9. Yeah. It's 4.
Okay. Once you are here, what will we want to do? Yeah.
Which is the concentration. Then you just get converted. Using the
The solid just goes here. How
Okay.
Oh, I didn't have the water.
Okay, so that's the problem.
You got a lot
I'm like,
wrong,
well,
man.
so
Now,
So this looks much better. Okay, yes, good. Yeah.
Is it the case where it's I got a valuation? Or
no, I'm saying, let's not make others two.
This is the number of
How do you know that? The steps are, you know, but all in all, yeah, well, I'm not expecting like, you know, perfect how many steps in this point, I just want you to know that you know. How did it go? Yes.
Yeah.
Okay, so remember though. That's. Yes.
You got that. Yeah. Yes, I can't say that. Wait. Oh, it's fine, it's fine.
Right?
So,
Answers are 1, 2, 3.
I might put 1, 3, and 2.
Like answers, there's like 5, 8, 4, 50, 7, 20. Let's have one on Stripe.
Concentration time.
I'm gonna try
Okay, so you with this and then that.
I don't want anyone.
I'm gonna kill myself. I'm gonna kill myself. I'm gonna kill myself. It was really fun. It was fine. My dad. I did not force it. I really did. There's one other than chat.
But
I got my brain.
Fine.
I first did not kill myself. I did my.
Yeah, it's cool. I know, I think.
Go do something. I'm gonna be proud. Oh, that's definitely this is my 75. Really? I'm gonna go. He just like, he's like, oh, it's all good. Yeah. Mr. W. Wow. Bro, I'm so pissed. You know, I'm sorry. I'm sorry. I didn't actually know. You're really good at it. Actually, yeah. Oh, yeah. I'm gonna tell you what.
All this is.
I like Here we go. You're about to show how good I Those are very. Hold on.
You wanna play it?
Once again, once I sending all my applications, bro, I'm in love with it. I'm high as okay. So you better put in some respect. Yeah, well, I would be high as like if I still played the game. No, you would not. No, I think 71 like a year ago. No, you would not.
Are we ready? Are we ready for Colger to show us how it's done? Yes? You can check your work?
We'll dissociate KiO3 into its ions, which are K plus and IO3 minus. And we'll also dissociate CuNO3 too, to give us the ions Cu2 plus and NO3 minus. NO3 minus, or nitrate ions, and K plus ions are both spectators, so we can discard them from our discussion and tidy up. We'll show Cu2 plus ions in the beaker, like this. When we add a small amount of solid KiO3 from the spoon, we're actually adding IO3 minus, or iodate ions, to the beaker. If the concentration of iodate ions is high enough, some of the ions will move together and form the precipitate CuIO3 or copper-2 iodate. We want to know exactly how much KiO3 needs to be added to just start the formation of the precipitate copper-2 iodate.
Okay, so I would say Colger doesn't use the first step, but he actually does the first step. My first step would be identify who will be precipitating, and that would be our CuIO3. That would be step one. Who is the precipitate? Yes? No, it doesn't, but you are asked what mass of solid IO3 minus would be needed to just start precipitation of copper iodate solid. So that tells us that copper iodate will be the one that we're concerned about. Yes?
Since we know that the precipitate would be copper-2 iodate, or CuIO3, we can now add that to our question. There's lots of steps needed to complete this problem, so it's best to create a plan first, listening in steps. Step 1 is to write the solubility equilibrium equation for the precipitate CuIO3.
In other words, the C.
In step 2, we use the equilibrium equation to write the Ksp expression. We can easily determine the concentration of Cu2 plus from the given concentration of copper-2 nitrate. So in step 3, we put this into the Ksp expression and solve for the concentration of IO3 minus needed to just start precipitation. In step 4, we use the fact that there are 2 liters of solution to convert the concentration of IO3 minus to moles of IO3 minus. We're asked for the mass of the compound KiO3, so in step 5, we convert moles of IO3 minus to moles of KiO3. Finally, in step 6, we'll convert moles of KiO3 into grams of KiO3. And that's the mass that we're asked for. We'll start by writing the equilibrium equation for copper 2 iodate. Notice there is one Cu2 plus and 2 iodate ions. The Ksp expression is Cu2 plus times IO3 minus squared. In step 3, we want to find the concentration of IO3 minus. We start by rearranging the Ksp expression to solve for the concentration of IO3 minus squared. Taking the square root of both sides gives us the concentration of IO3 minus is equal to the square root of Ksp over the concentration of Cu2 plus.
Would you like me to pause this?
Yes.
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 Is this a good place to pause?
Yeah.
Okay.
Yo, better now.
Is that his phone? Leave his phone alone.
Hey, better not open the iPhone. Miss Spence, are you participating in?
I didn't know when to go get the thing and where, so no, but at the same time, like I have very often left my phone at home and not noticed. So, and my phone dies and I'm like, oh, and then I don't realize I've left my phone at school over the weekend, right? Like, I know, and you guys are like, what do you do? I use a computer. I have old eyes. Why would I look at something on a tiny little screen when I can use my computer? Right? And I'm just not, the only thing that I use it for, if I'm hanging about, is to read my book. Because I got books on there. But I can read a paper book as well, so. What's a book? Oh, bless your heart. What's that? A strange concept of paper use? Oh, what a strange, yeah.
We'll rewrite this expression up here. And we'll replace the symbol Ksp with the actual Ksp from the table. Looking up the Ksp of copper 2 iodate, we find that it's 6.9 times 10 to the negative 8. So we substitute 6.9 times 10 to the negative 8 for Ksp in our expression. Now we have to find the concentration of Cu2+. We see at the bottom that the solution was 0.01 molar copper 2 nitrate. Looking at the dissociation equation for copper 2 nitrate, we see that the coefficients on Cu2+ and CuNO32 are both 1. So since the concentration of CuNO32 as a whole is 0.01 molar, it means the concentration of Cu2.
Can you pause it?
Yep.
What goes in the thin box?
I don't know. I don't have a book. Which thin box is he talking about?
The answer or the
concentration.
Yeah, the concentration. Yeah, of IO3 minus. No worries. No worries.
Plus from the salt is also 0.01 molar. So we'll substitute 0.01 molar for the concentration of Cu2+ in here, like this. Dividing 6.9 times 10 to the negative 8 by 0.01 and taking the square root gives us the concentration of IO3 minus is 2.63 times 10 to the negative 3 molar, or moles per liter. In step 4, we want to calculate the moles of IO3 minus in the solution in the beaker. We see at the bottom that we have 2 liters of solution. Because moles is equal to molarity times liters, moles of IO3 minus is equal to 2.63 times 10 to the negative 3 moles per liter times 2 liters, which equals 5.26 times 10 to the negative 3 moles of IO3 minus. In step 5, we want to find the moles of KiO3. KiO3 contains one IO3 minus, So moles of KiO3 equals 5.26 times 10 to the negative 3 moles of IO3 minus times 1 mole KiO3 over 1 mole of IO3 minus.
Or you can just say they're equal.
And that equals 5.26 times 10 to the negative 3 moles of KiO3.
I'm feeling the voice out.
In step 6, we want to find the mass of KiO3. So we take the 5.26 times 10 to the negative 3 moles of KiO3 and multiply it by the molar mass of KiO3, which is 214.0 grams of KiO3 per 1 mole of.
So Alvin, I feel like maybe your problem was you did the mass of IO3 minus by itself. Is that possible? Did you have 214 grams per mole? Yeah? Okay, so I don't know what you did.
KiO3. Notice the moles of KiO3 will cancel out. And the final answer comes out to 1.13 grams of KiO3. Some of the values we used in this problem were only two significant figures, so we'll need to round our answer to two significant figures, which is 1.1 grams of KiO3. So we can say that 1.1 grams of KiO3 would need to be added to 2 liters of 0.01 molar copper 2 nitrate solution in order to just start precipitation.
Okay, so that is, he apparently doesn't care if you say more than whatever, so just put equals. Yes? That is how much is needed to just start precipitation. That would also be the maximum amount you could add without starting precipitation, which is a little confusing, but just go with it. Okay?
Now, if you put in exactly this amount, it is right on the verge of starting to form a precipitate.
He's saying here.
You wouldn't notice any precipitate yet. If you added a tiny bit more, then you would start observing a precipitate. If you want a copy of this problem and the whole solution, you can just pause the video and make a screen capture of this slide now.
Guess what your teacher did for you? Okay, never mind. Oh, so many screen captures. Okay, now, you guys know that lunch is later today, right? But you guys are leaving early because you have somewhere to be? Yes. Okay. Okay, those of you who are leaving, leave quietly. The rest of you, we're going to carry on. We have our 5 steps on page 76. Okay, so you will follow those steps for this type of problem. Identify the precipitate, write the C, write the KSP, plug in the KSP value, plug in the 1 ion concentration that you are given, and solve for the other concentration. Yes?
If on do we have to write like the center?
No, I don't think so. No. Do you guys want to try the example on the next page? Give it a go. See if you can do it faster this time. See if you can beat me to the answer. Oh, that'll be exciting. See if you can beat me to the answer.
Oh, you create some.
Yes.
Do you have to follow these exactly?
No, but this one, you have to do this one, right? Because that's going to get you marks in a written response question. You have to do this one because that's going to get you marks in a written response question. This will get you marks in a written response question. If it's multiple choice, you don't have to show anything. You know what I mean? Yeah. But you don't have to write, you don't have to write telling me what the steps are. I'm just scripting for you. Yeah, no. Thank you.
Yes.
I'm at the park. Holy moly. What were you thinking? What is that?
Oops, I must have done something wrong here. Oh, what happened there? Okay, that's where it went. Yeah. This is a 7.
Yeah. No one tries to go all the way down.
they're not there yet.
Yo, you know where it says like this written in block for like just putting your order.
Is that what you guys got? Yay! Was it easier the second time around? Good. Yes.
Do you like Subway?
Do I like Subway? No.
That's embarrassing.
It doesn't taste like food. But I've never been big on sandwich meats either, right? Like they don't taste like they're salty and their texture is weird. Right? I don't know. Like I will eat them and I would prefer something that tastes completely unlike a normal meat like salami or something to like processed turkey or chicken. I'm like that just tastes weird. Because I'd rather just have like turkey or chicken like roasted or something, right? It's just better. I don't know. Six, 7. Okay, since you guys didn't do these problems, we're going to add on to this. Because I was going to add on to it for the weekend because you need more practice than just 2 questions per.
Yeah.
Thank you.
Oh no, she had a
Oh, I'm so cool.
Oh, pictures. Yeah. Oh, okay. Is that?
Or your glasses out.
Yeah, that's out.
I'm gonna
Just
go
a big
back.
bag. Oh, yeah.
I gotta try your barbecue full court. No, you don't. Stop. No, this is next. I can put it next day. Wait, is there?
Yeah, I know. How do you do it? But I don't know. I just feel like, because I talked about it like last year,
Is it sold at
last year,
Autumn
like,
Plaza?
Yeah.
And you go in if you're not going to fly with them.
Oh,
because I had it last year.
However, Canada, you're going into a theater.
Should I be like,
Bro.
how are you?
Or you're going out with us.
Yeah. Like, ask them if they have time or if they have any time. Because I'm the same way. They might have time.
Okie dokie, if you can do more, you can do more, but that's, like, you should really do that many to feel solid. Yeah, it would have been better if you'd done some yesterday, because then you could review it over the weekend. And that would be, then we have a stronger connection, but you didn't do that most of you. Some of you did, those of you who did, yay, thank you.
the maximum.
What's the maximum number of questions you have to do in order to precipitate? Okay, sorry, yeah. Alvin, I'm sorry.
Thank you.
It was good, it was good. It was very apropos.
Maybe I'm looking into I went to if you find it, then probably would get to you. Yeah.
You study like it's a university.
Photos or when you
Good morning, everyone. Just a reminder for those of you partaking in Phone Free Fridays, there are board games and activities in the multi-purpose room during lunch. We hope to see you there. Thank you.
Oh, good job. Yeah, but don't you have Christian
Well, I can just get it from downstairs.
I was trying to. You go.
I will update them. Probably this weekend. Probably.
Well, this really has a lot of $50. How many notes are on there? He said he mentioned it was at least
Makes more sense.
Thank you. I didn't use that paper. That's fine.
I didn't blow up that. How you not? Oh, sorry, I don't know. Okay. You can almost drop.
You can't hear it.
Yeah.
Yeah. And you'll admit that.
Along with
Well,
that,
yeah.
Yeah. What'd you forget?
Oh, sorry. I think where I was going. Yeah, there, thanks.
Thank you so much for letting me use it.
No problemo. Guys.
So is solubility of a salt its molar solubility?
Unless otherwise specified, we'll assume it's molar solubility. Yeah.
We might need to go to the.
Oh, yeah, but not gonna touch the wall and all that line. I talked yesterday for the drill.
Oh, I know. Thank you, Miss Faye.
You're welcome.
Thank you, Miss Ben.
And then you I will walk